Want to welcome everyone. Our participant room, our guest room is filling up really fast. We're really glad to have you here this afternoon. It's me, James Stevenson, here with the University of Florida Institute of Food and Agricultural Sciences, your extension service right here in Pinellas County. And we're bringing you Nature University, a series on the weird and wonderful nature right here in our tiny little county. And part of that nature, one of the things that defines the nature in our county is, of course, our climate, and on a much smaller scale, our weather. And we're very, very glad to welcome back Spectrum Bay News 9 meteorologist Brian McClure. Brian is our favorite, although we're not allowed to have one because Brian loves to explain things just like we do. About how things work and the bigger scheme of things, and how the tiniest little aspect of nature is affected by these, even global patterns. And today we're going to take a look at some of those driving forces, the fronts and the pressure systems. Has everyone felt a little bit under pressure lately? Maybe a little bit? Maybe it's one of the pressure systems. So today, we're going to welcome Brian McClure to bring us through the highs and lows of pressure systems and frontal systems, and help explain how we get to where we are when we wake up in the morning, especially on days like this beautiful weather. So welcome back, Brian, and take it away. We'll be monitoring the chats and questions throughout, and we'll break in if we need to, and have some time for questions at the end as well. So
okay, fantastic.
Thank you.
All right, thank you very much, James. I appreciate you having me. I will go ahead and share my PowerPoint so that everybody can see that. Let me make sure that I get it just right for you. Okay, close that. Well, almost. Wouldn't you know? We even went into testing and got this just right, and now all of a sudden Zoom is showing some weird funky Java things on my end, but don't worry, we'll get it. We always do. James and I were just talking about that before we even started. I said every single talk something has come up.
Every day's a school day. We're always going to learn stuff. But just while Brian's learning his screen, just take note that you have the ability to ask questions in the Q&A. You can just click that Q&A. There's also a chat function. So Julia and I will be monitoring that and coming in with some questions here and there. Just while we have a second, I also want to mention on November 18, same channel, if you will, right here. You can sign up just like you did for today's program. We're going to bring you Florida birds through the season. We have a volunteer, Brian, another Brian, who's a nature photographer, and he's going to take us through the seasons of Florida and the kind of species of birds that you might encounter, a lot of whom get pushed into Florida by some of these fronts. So we good, Brian?
We are good. Yeah, that's exactly what it was. It was a little Java icon thingy where it got in the way. Remember how we were talking about even before this started, I was trying to do two programs at once? They don't like each other.
I'm glad you sorted it out. Thank you, Brian.
Yep. All right. So now you should be, and just confirm for me, you should be seeing the PowerPoint on your end full screen, James and Julia.
Yeah, we got it. Looks great,
okay.
Brian. Thanks.
Cool. All right. Well, in that case, then let's get started. Let's get right into it. Yes, I'm meteorologist Brian McClure. I'm the evening meteorologist at Spectrum Bay News 9. If you have Spectrum cable, then you can watch me. If you don't, even if, by the way, new little feature, if you have just Spectrum Internet, they have come out with a new package where for free, you can also watch me through the app that we have, a Spectrum News app. So that's kind of a new feature that I like that they did, because let's face it, a lot of people are just doing internet these days. So that's a neat feature. All right, so we're gonna be talking about high pressure, low pressure, fronts, and what controls the Florida climate and weather. But to do that, we have to get back to basics. And if you took the 101 class that we did, what was it, a few months ago, then I discussed this briefly. And I'm not going to spend a lot of time on this because obviously this goes back to like elementary and middle school basic science. So we can do this research on our own or studying on our own at a different time. But I at least wanted to show you where it all begins. You've got seasons. You've got, of course, the tilt of the Earth axis, and you've got rotations around the sun. And so what ends up happening is that this results in different heating and cooling across the globe. So therefore, that gets everything moving. All right. That's usually one of the most basic questions from first and second and third graders. And it's actually a good question. They'll go, I don't understand though, how does it all get started? That's how it all gets started. If you have a disproportionate amount of heating on one side of the globe or one part of the globe and cooling on the other, or darkness and light, you're going to get warm and cool air moving towards or away from each other. That's just where it begins. Let's study the basics first. Low pressure on a map. You probably know it as the big red L that you've seen on TV screens. I'm not the only meteorologist in the area. We have tons of meteorologists, and they'll show these L's and H's on the screen. When you see an L, what you need to know is low pressure means that there's less pressure pushing down on the atmosphere. So therefore, air is going to go up. When air rises, it cools, condenses, and therefore coalesces around clouds. Moisture particles will form clouds. And then, of course, if you get enough moisture, that's when you can start getting active weather. Precip, rain, sleet, snow, hail, thunderstorms, tornadoes, all that good stuff. High pressure does the complete opposite. It squashes the atmosphere. So the way to think of it is it lower pressure above us or is it higher pressure above us? Sometimes the kids will get confused because they'll think of low and high as, am I short or am I tall? The way to think of it is the pressure is always here, but is it stronger, higher pressure or lower, lesser pressure? That's all it is, okay? So when we show you an H on the map, that basically means we're squashing the atmosphere with higher pressure. And actually looking outside today, I had the window open right before doing this talk, but I thought, well, I better close it because you never know what you're going to hear outside as trucks roll by. But I had the windows open again, third straight day. It's gorgeous outside, feels fantastic. High pressure is in control of our weather. What will happen, and this is actually going to play a big part in our forecast headed into this weekend, is that high pressure will nudge out and we're going to have a low pressure moving towards us from the south, from the Caribbean. And if we have time later on in the talk, we'll even try and show you some current conditions, because obviously in a PowerPoint, I am showing you some past things and I'm kind of building towards it, but it might be interesting to show you some current conditions, actually what's going on right now. So when you look at the high and the low pressure, this is a good representation all on one graphic. High pressure pushing down, low pressure, therefore allowing the clouds to build up. Why this is important here locally in our Florida sea breeze. I also touched on this briefly in the 101, but I wanted to hit on it harder in this 102. Florida is fascinating because unlike all the other states, we're surrounded by water almost on all sides. And in Tampa Bay, we literally have water almost everywhere, especially if you're in Pinellas County, for example. You have Tampa Bay, you have Gulf of Mexico, you have the Caribbean, and you have the Atlantic Ocean. So you have all this water. What we have to understand is that cool air will rush towards the warmer air. But you might be wondering why. Here's why. Look at this map, this chart that I have up, and you'll notice that our sea breeze moves from the water towards the land because you have to go back again to elementary school and remember, where does warm air go? Warm air rises. Okay, well, if warm air rises, that is acting like a low pressure. So your air will move from the cooler water over land, and then it will rise. And then it will move back out towards the ocean above, and you have descending air. So that's our sea breeze circulation. Okay. And then at night, you might have heard us talk about this before. You can get a land breeze where it reverses the descending air. The land is cooling faster. So the air descends over land, and then therefore it rushes out towards the water at night, and you have rising air out over the water. So a lot of times you'll notice in the summertime pattern that we have, this typical sea breeze, the morning is nice, it's sunny, sea breeze comes in, clouds start to build, you get the thunderstorms, and then at night, thunderstorms work their way back out towards the Gulf of Mexico. It clears over land. You look out there in the Gulf, and there's big thunderstorms. It can do that a lot. But in our pattern, it's not just that simple. Because we are surrounded by water everywhere, you also have to look for which way the dominant wind direction is coming from. So let's say there isn't a dominant wind flow. In other words, there's no cold fronts, there's no high or low pressures close to us. And instead, it's just what I would call a normal July day where it's hot, it's muggy, it's humid, and the winds come in from the Gulf and they come in from the Atlantic. What will happen is they will meet in the middle, and that's what we call your sea breeze collision. And typically early in the season, they'll meet almost dead center, Polk County. And then as you get later in the season, because the water temperatures warm up so much, I mean, our water temperature tops out around 90, 91, 92 degrees in the summertime. By that time, the air doesn't flow as quickly in from the Gulf of Mexico. Because once you get your air temperature and your water temperature about the same, the air might just barely drift in. So then your sea breeze tends to hug closer to the coast later in the season. That's an interesting little Florida factoid that people outside the state don't get. And sometimes even people inside the state don't understand. Like, wait a second, why in May and June does Polk County get all the big sea breeze thunderstorms? And then come August and September, it's like, hey, how come those thunderstorms aren't coming as far inland? That can happen a lot. But if there is a dominant wind flow, let's say from the east or from the west, let's take west first as an example. We would call this an onshore wind flow pattern. Sometimes we also call it a reverse summer pattern, because if we get a strong enough west wind coming in from the Gulf, we will get morning passing showers coming in from the Gulf, and then they will scoot to the other side of the state really fast so that by the afternoon to evening, they're all on the other side of the state, Orlando eastward towards Port Canaveral and the Atlantic. If we get an east wind flow, the opposite will happen. It will keep our sea breeze pinned and pushed back, almost like a fence right near our coast. And the afternoon and evening thunderstorms will come across the state, bump into that, and we get the big explosion of storms on our side of the state late in the day. So it does work both ways. It's really kind of fascinating. When you talk, then you go from that. So think of that as like June, July, August. Go from that to larger scale. Okay, Brian, that's our summertime pattern. That's just the day-to-day sea breeze interactions, bay breeze interactions, hot and muggy weather and moisture. So we get thunderstorms almost every single day in the summertime, but then it's just a matter of how many and where do they move. You transition in Florida, especially here in Tampa Bay. What I love about the central to southern part of Florida is it's not purely tropical and it's not purely continental. You kind of fall in this realm of subtropical area where you can get the tropical moisture coming up from the south. So let's say, for example, on this particular graph, you have the Bermuda High sitting right there. And with the clockwise rotation around that high, it will help to pull that moisture right up into Florida. That is very normal, even all the way into August, September, yes, even October. And believe it or not, it can even happen in the wintertime because the tropical moisture is lurking. It doesn't go far away. It kind of gets pushed and nudged down to the Caribbean where it is purely tropical, and it can get pulled back really fast. And that's why Florida falls in that subtropical zone. We can kind of go back and forth. And you're seeing that right now, actually. So for the past couple of days, oh, it's felt great, right? Less humid, dry air, cooler, feels almost like Georgia, right? Well, give it a couple more days. And this map that I'm showing you right now is a perfect example of what you will see where moisture just comes flying back really, really fast. This is a perfect example of what we just saw happen 3 days ago. Sunday night, we had a strong cold front come roaring in, and that cooler, drier air came blasting through the area. And ironically, this is about where it stopped. It stopped right about Cuba. And so this is just an example of something that I made. But this example is very, very similar to what happened. And all this moisture is still down here. So it doesn't go away. Moisture doesn't go away. It just moves. When I'm talking to the little kids in elementary school, when I give their school talks, they have a hard concept with water cycle. And I tell them, don't think of water as going away. Think of it as sometimes it can disappear, but it's still there. You just can't see it. It's always out there, but sometimes you can't see it. Sometimes you can't feel it. And then sometimes you can feel it and sometimes you can see it, like fog or that mugginess that just kind of emanates off the pavement when you get a hot summertime thunderstorm off the black pavement. The water's always there. So the way to think of fronts and air masses is we just pushed all that dry, cool air down into Florida and it pushed the moisture down to the south, but it's going to come back. So this is an example, an actual example of a map that I just grabbed for you yesterday. And this shows high pressure. It shows the north wind. Okay. And this, don't worry too much about colors, but for this particular purpose, this color basically means dry air. All this is dry air. And then the reds and the yellows down in here, that just means tons and tons of tropical moisture. So you can see the moisture didn't go anywhere. All right. It's just lurking. It's down there near where Hurricane Eta made landfall in Nicaragua, okay, in the Caribbean. And by the way, yes, it is very, very common to still have tons of tropical moisture lurking and lingering in the Caribbean, even in October and November. And if it's like a season like '05, which unfortunately it looks like it's going to be, it can even lurk down there through the wintertime, December and even into January, because it takes a while for these multiple cold fronts to go down there and keep pushing and pushing and pushing against it. In other words, a lot of times the moisture wins out and the dry cool air does not, because the dry cool air has to come all the way down from Canada. Whereas the moisture, it doesn't have to go that far. It just has to make it up and over the Cuban Peninsula, and then boom, it's into Florida. On this map, this, again, don't worry as much about colors. What I'm really trying to illustrate here is how a meteorologist looks at maps. So my job every day is look at tons and tons of maps, not just to the US, not just to Florida, but all across the globe. Where are high and low pressures? Where are cold fronts? Where are warm fronts? Where's the moisture? Where's the dry air? And put it all together to make a story, to put it together so that you can see the presentation, you can understand the presentation. So if I were talking this week, which the past couple of days I have been, about this big high pressure, I've been saying, hey, this is why that high pressure is keeping Hurricane Eta to the south and why it made landfall in Nicaragua and was not allowed to come north. This high pressure that is right in there is also what was responsible for pushing not only the moisture out, but pushing that cooler air down towards us. And that is also why you look outside and it's sunny out, because it's also pushing down on the atmosphere. So it's doing a lot of things. It's not a linear type thinking. It's more of a, you have to realize a high pressure is doing multiple things and a low pressure can do multiple things. There's a lot of stuff going on in the atmosphere. It's very fluid, no pun intended. That it's just, or maybe I should say pun intended. It is a fluid science It really is. It's always moving. And so the way you have to think about this is, where are your highs, where are your lows, where are fronts, where's everything moving? And you have to time stuff out. So if you're ever interested in being a meteorologist, you have to be really good at math and science, because you're always predicting the future and always looking into the future. And you have to know where things, what they've done and how they're moving before you can predict the future. This was a map I grabbed yesterday showing, there you go, high pressures across Southeast. Now, yesterday just happened to be one of the best, most perfect voting weather days I've ever seen. I mean, other than a little bit of rain way up in Washington, it was pretty much a perfect election day from coast to coast, with no weather and high pressure in control. So that just goes to show you how important weather can be. If you're one of those big history buffs, with, I know a lot of people are not, but if you are, some really neat books to read would be how weather has affected history, such as wars and global events. There have been some people that have even said things like, written about how, like, for example, on September 11th, unfortunately, that tragic event, if we would have had worse weather, maybe morning fog or clouds or showers and storms, those planes might have been delayed. So weather can affect and have a major outcome on history. It's really, really fascinating. So yes, for this election day this year, beautiful weather. I took a screen grab of the national radar, and look at that. There was almost nothing. Isn't that amazing? Look at that little bit of rain way up there in far northwestern Washington, which, by the way, is very normal. They get rain almost every day. And there were a few little rain and snow showers right there, and a little bit of snow shower activity way up in Vermont. But I mean, that's about it. There was almost nothing going on yesterday. All right. So now let's get into the meat of, if you tell me highs and lows are pushing down and pushing forces, can they be pathways? Can they make pathways for things to move? Absolutely. This is where we transition to, again, Florida is so neat when it comes to weather, because we're always tracking all these things. But while you're tracking them, you have this tropical component, because Florida sticks out there into the tropics. And so you're always watching, at least as a meteorologist, I've always got my eye going, what's going on out there? I'm always watching the Gulf and the Caribbean, the Atlantic. Look at this map from last week, or was it 2 weeks ago? No, it was last week. Zeta, Hurricane Zeta, was moving towards the US. It was coming past the Yucatan. It was right about in here, okay? And you had this big low pressure in the jet stream, okay? Right there it was, near Texas. You had this big high pressure over us. Does everybody remember how hot and dry it was last week? It's hard to remember because it was, we've had beautiful weather now for a few days, but it was only a week ago. We were breaking record highs, low 90s. It was dry. That's why. We had a very strong high pressure on top of us. One of the things that I try to illustrate and talk about in my evening weathercast is, if there is a really, really, really cold, strong, low pressure on one side of the country or in one part of the country, there almost always has to be an equal force in another part of the country. So if it's really cold here, it has to be really hot here. If it's really low pressure here, there has to be a high pressure here. They have to balance each other. The atmosphere is a constant seesaw trying to get to equilibrium, but it never makes it. It's always doing this, but it's trying to get to here. It's trying, but something always nudges it off. So sometimes it's just barely nudging like this, kind of like right now. It's just kind of near equilibrium. But in a couple of days, it's going to do this. And then guess what's going to happen? Something's going to have to come along and go, uh-oh, no, let's try and get it back. And so that's why it ends up doing this. This map is a perfect example of high pressure was over us, hot weather, dry, low pressure, really, really cold. I mean, there was a lot of cold air that was coming down in here. There was snow down into Texas and New Mexico and Arizona. And you had this hurricane, classic late October, where, wait, you got snow, you've got hot air, and you've got a hurricane? Yeah. 400 miles apart from each other, you had heavy snow in Texas and a hurricane headed for Louisiana. Well, look at the pathway. Low pressure in the northern hemisphere is counterclockwise rotation. So therefore, the winds were blowing like this, and high pressure in the northern hemisphere is like this, clockwise. So it went right between the two. It's science. It makes sense. And that's one of the reasons why we've gotten so much better in the past 20 years at predicting where hurricanes will go. We still have a lot of work to do on intensity. We need to do a ton more research on that part. But the path, we have gotten so much better on because we can analyze high pressures, low pressures, and what's going on in the atmosphere. So sure enough, a little bit different style of showing it, but this shows you the cold air around the low pressure, the warm, hot air around the high pressure, and there's your path. There was your hurricane right there. See it right there? And the reason, by the way, that Zeta made landfall and then hightailed it like this, it was going around the western side of the high pressure ridge, but this low at the same time was moving in that direction. So what happened was this little funnel path kind of bent over like that. So as this low moved out, it slung it that way. So think of it almost like a slingshot. You had this wind coming around like this, you had the winds coming around like this, and the hurricane came right into that funnel and then went whoosh right out, just shot out like a cannon. And it went right out. I mean, in under 24 hours, it went from a hurricane category 2 striking New Orleans and Louisiana to it was a blob of rain, no tropical system, and already off the eastern seaboard past New Jersey. It was that fast. I mean, just whew, took off. It all comes down to pressure systems, wind movements. Let's look at right now. Okay, this is a current map, or at least I think it was yesterday's. I think I grabbed this yesterday. Maybe I grabbed it Monday night. Either way, I grabbed it in the past couple of days. This is your high pressure. You can see it is rock solid. It is firmly in place all the way from the deep south to the northeastern US. So you had cool air come barreling southward, and this high pressure came in behind it. And that is why we've had 3 straight days of gorgeous weather, because that high pressure said, that's it. Fencing off gorgeous weather. And it basically built a fence right down here, right there. And so this was Ada, Hurricane Ada, and it could not go north. No way. That high pressure said, no way. You are not coming up this way. So instead, it moves it west. That's how we predict weather. We start to look at everything going on globally and across the entire continent and other continents. And we start to put together the pictures, or the pieces, I should say. So you start big picture, and then you work your way down. So big picture is high pressure's in control. Nice weather, less humid, drier air. Rain chance goes away. Then you come down to regional and you go, okay, which way will the winds be blowing from? If it's north, it's going to be cooler. And if it's east, it'll warm up a little bit. So each day we went from north wind to northeast, and now we're getting more of an east wind. So all of a sudden what starts to happen is you start to hone in on the local forecast. And that's how we start to say, oh, well, the high today is 81 versus yesterday when it was 78. Those are the little nuances, okay? But this talk was meant to be more about what drives our weather, what's really the big factors. And there you can see the big factors. In a couple of days, well, maybe about 3 or 4 days, but in the next few days, what will happen is the remnants. By the way, Ada is dying, okay? So when you hear meteorologist or see forecast of, wow, we could get a tropical storm coming towards Florida this weekend, it's not that it's surviving its run across Nicaragua and Honduras. No, That's not how it works. It's falling apart, and it will fall apart. But there will be left behind a general area of lower pressure in the Western Caribbean. And that's very normal this time of year. So, what ultimately ends up happening is that the remnants, the moisture and the broad leftover circulation from dead Eta will come back to life. It will start to reorganize. It'll pull all that moisture, start wrapping it around. And most likely by Saturday or Sunday, you're going to start to see a new tropical depression developing right about in here. So at that point in time, here is a general idea. This is just model guidance. It doesn't mean it's gospel. It doesn't mean it's going to happen 100% sure. But this is a general idea of high pressure in here, low pressure back across the central and western part of the country, and a low pressure trying to develop south of Cuba. Well, do you think this low can go up against this high? No. So what it's going to do is it's going to try and nudge where there's lower pressure, either right in here or out in here. It always wants to go around high pressures, okay? And since it can't go this way, at least it doesn't look like it can right now, it's probably going to go this way. And that is why you'll notice a lot of the forecasts are saying, hey, we might actually have a new tropical system coming towards Florida. If there's enough of the structure from old Eta left behind, they'll just give it the same name again. If they feel that the structure has been totally gone for 2 or 3 days, and let's say it takes till, I don't know, Sunday to redevelop, they might give it a new name. As of right now, the latest NHC forecast says they're just going to keep the same name. They think that there's enough structure left that even though it dies completely, it comes back as a depression quick enough. It comes from the same remnants. So therefore, it will keep the name. So we could be looking at reincarnated Eta coming up towards Florida. This is how, when I'm on air, I give forecasts. I don't know if people listen or not because it's only a one-way communication when I'm on TV. I'm delivering the forecast. I have no clue if people are, have their TV on mute. But a lot of times it's almost kind of humorous. On social media, people say, Brian, I know you said on TV that it'll be 81 tomorrow and beautiful, but tell me really, what's it going to be like? And I giggle. I go, what do you mean? I'm being honest. I do not change from off air to on air. I know some actors do. I mean, after all, that's their job. I know when they're playing movie parts and TV shows, they have to act one way on the show and then act a different way in real life. That's not me. You're going to get what you're going to get from me. And when I go on air, I actually do show maps that look exactly like the one you're seeing. And I have shown this on air. And I'll be honest with you, the first few years I got the job here in Tampa Bay, my bosses didn't like me too much. They said, you're pretty technical. You're really showing some pretty sciencey stuff. You sure that, the public's going to like that? And I said, I don't know, but that's who I am. I love explaining the atmosphere. I find it fascinating. I find the science fascinating, and I want to share it. So I will show maps just like this on air. And luckily, my bosses have embraced me. I appreciate it. And they allow me to show very sciencey, techie stuff like this. And you can see this high pressure. A few years back when Irma was coming at us, I was talking about, now look at the western edge of that high pressure. That's what I was pointing out. And I said, hey, because of that high pressure, if it nudges any closer to Florida, then the western edge of that high pressure will keep moving towards Florida. And that means Irma will come right up towards Florida. That's what I was talking about. And sure enough, multiple days out, like 5 days out, I was talking about how most of the models were all hinting and coalescing around this idea of, it's coming right towards Florida, and then it's going to make a northerly turn. The good news is, by the way, if you're looking at the tropical forecast for Ada right now and going, uh-oh, it looks like it's going to come right up from the south, don't stress too much about the path. Don't forget that it has nothing to do with intensity, okay? Ada is dead as a major hurricane. It's decimated. Anytime hurricanes go into Nicaragua and Honduras, there's really high mountainous elevation down there, so they just fall apart. Now, will it grow back to a tropical storm? I think so. It might even be like a subtropical hybrid type storm. But the main point here is this late in the season, it's really, really hard for a Cat 3 or Cat 4 to make it all the way up into Florida. And the reason being is because we already have had a few cold fronts. So our water temperatures are much, much cooler out there. I just looked at them yesterday, and instead of being 82 or 83 like they were last week, they're like 73. So they've dropped like 10 degrees in just a matter of 1 week. Okay, that's really hard for a major hurricane to thrive on that cool of water. So that helps. The other thing that helps is you get lots of wind shear this late in the season. So I think it's going to be hard for the next tropical system coming up from the Caribbean to blossom into a major hurricane. Could it maybe make it to hurricane status? Possible, but that might even be difficult. So just pay attention to details. Don't stress too much about path. Look more and listen more to what are we saying intensity wise. This is a cool map because this then puts into perspective how you can get really breezy winds. I know James commented on this, I think during my last talk, how he likes to listen to how when I give a science lesson on air in the evening, I like to talk about things that maybe are not common speak in the real world. There's such things as pressure gradient winds. And so a lot of times in Florida, we will get pressure gradient winds. Remember, counterclockwise rotation around the low, clockwise rotation around the high. Well, if they get close enough to each other, remember how I was describing how Hurricane Zeta was shot out like a cannon between the two? Well, this can happen around here. You can get winds funneling between those two, low and high pressure, and that's a pressure gradient wind. And it just whoosh, it will fly between those two, and all of a sudden your winds will increase. Well, sure enough, if you want to know why it's breezy out again today, it's not because Ada is anywhere close to us. Ada is thousands of miles away. No. But what it is because of a pressure gradient between lower pressures down here near Ada and higher pressures to our north. So look between the two. Voila, there you go. And so I grabbed this, I think yesterday or 2 days ago, to illustrate how this going on right now outside, I can see the trees are swaying in the wind outside my window. That's a pressure gradient wind. And we're going to have that every day this week. It might even strengthen more so that, for example, let's say this low pressure does develop. Let's say I'm right and it does become a tropical storm like up here near Cuba. But this high pressure is not going to move that far away. It's just going to kind of nudge a little bit to the northeast. You're going to see this wind get stronger and stronger and stronger from the east, so that by the time we roll into like Saturday and Sunday, you could be looking at an east wind of 20 to 30 miles per hour, and it has nothing to do with a tropical storm being over us. No, it's just a pressure gradient wind. And so, for example, there was a big fishing tournament down in the Keys for this weekend, and I've already had a lot of them calling me and emailing me saying, Brian, what do we do? What's it going to be like? And I'm like, oh, it doesn't matter whether this develops into a tropical storm or not. I would cancel the tournament. It's going to be way too choppy. That's how weather forecasting is important. I can already see that days in advance. Even if this doesn't fully develop, you're going to have a strong easterly wind. But hey, it'll actually make it kind of feel comfortable around here. So can't complain too much. James, I think I'm going to stop there. I do have some other graphics, but the best thing to probably do is to stop, and because I know you probably have some questions and you might even personally have some. And then that way we can always jump either back into a PowerPoint, or I can share some graphics of what's going on right now if something's related.
Very good. Thank you so much, Brian. That's amazing. And it just kind of just kind of scratches the surface of all kind of questions we, your panelists, and our guests might have today. I had one just come to me, might be an urban legend, but just curious. Do this that you mentioned kind of the way that the air moves around the high and the low system, kind of counterclockwise around a low, and that's what sets up the whole spin of a tropical system and hurricane. Is that opposite in the southern hemisphere?
It is opposite. It has
Okay.
to do with Coriolis effect. So that's actually science, not urban legend. It is fact. It is science. It is fascinating. Funny you mentioned that because I'll tell you what. Do you want me to pop up a graphic?
Sure.
Here, let me share this again. Okay. All right, and then there it is. How come I had a feeling that might come up? So deep down in my presentation, I thought, you know what? I better put it down in this PowerPoint just in case it comes up. Think about it like this, Coriolis effect, okay? Let's say you are a human standing on the top northernmost part of the North Pole. And in an entire day, the circulation or the rotation of the Earth, well, think about it. If you're right there at the North Pole, you're only going to rotate at a very, 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 very slow rate all day long. But now put yourself on the equator. You're going to go a whole lot faster to make that rotation. Well, because of that, Coriolis effect is what gives us the direction deflection. That's what I like to call it, direction deflection. Okay, so look at this particular picture right there. That's the most important one. Okay, so let's say air is moving in that direction like that. It will get deflected in this direction because of the Earth's rotation moving that way. And if air is moving this way, it will get deflected that way because of this strong Earth's rotation. Well, guess what? If you have air moving that way and air moving that way, you start to get the counterclockwise rotation. Well, in the southern hemisphere, it will work the opposite. As air moves this way, it's going to get deflected like this. And as air moves that way, it will get deflected like this. So then you get your clockwise rotation. So yes, it is truly a science thing. It's not an urban legend. It's not a accident. That is Coriolis effect at its best. It's really cool. It's kind of geeky, kind of sciencey, kind of technical, but that's how it gets everything moving. It also sets up, by the way, a really cool intertropical convergence zone between the two hemispheres where you get a lot of active weather. You get a lot of convergence. So near the equator, you can get just like lots and lots of tropical type weather, showers, monsoonal type weather. And that's why. There you go.
That's fantastic. Thank you. We do have a couple of questions, which I'm going to hold off to the very end. Kind of in the spirit of upcoming Great American Teach-In, are you taking part in the Great American Teach-In this year?
Absolutely.
Excellent. We do have a couple of questions for you personally about what it's like to be a meteorologist and how you got into it. But for just a minute, what did we have? We did have one question about the temperatures that might be associated with these systems, cool versus warm. If a warm air mass and a cold air mass were to encounter one another, the question, which one would be stronger?
Both can be stronger or weaker.
Okay.
Good question, because it's kind of like the flavor of the day. Sometimes the colder air wins out. The next day, the warmer air wins out. It can go both ways. When they mix, when they hit each other, that is where you get your active weather. But sometimes the colder air will do this and it will push the warmer air out. And sometimes the cold air is sitting here and the warmer air will go up and over the cold air. And so it, you could say, wins out, but either way, they clash.
Very good. I have a question. We have been many years now without a hard freeze in Florida. You know, we used to, when I was a little kid growing up, every couple, 3-5 years or so, we would have, you know, a hard freeze. And Dad would always say, oh, this is good. It's going to knock down all the bugs or whatever. We've been kind of free of a hard freeze. Is there anything going on, or is it just part of, you know, maybe a 10 or 100-year cycle?
We think that it is part of cycles. We haven't honed in on the exact Florida cycles, but we do know that we have relations to things like La Nina and El Nino. There are also, oh my goodness, there are AMO patterns, MJO patterns. There are all kinds of large-scale global patterns. But keep in mind that we have a really, really, really interesting microclimate around here. And we talked about this in 101. Citrus and Hernando County, if we have anybody up there listening, which we might not, but if we do today, they're probably going, James, that's not true. It froze at my house last year again. And it's funny because as a meteorologist, I get those kind of comments all the time. No, you're not talking about me because in Citrus County, it was 23 degrees last winter. But I know what you're talking about, like deep down into Pinellas and Western Manatee County, close to the coast where it's always warmer. Have we gotten a deep freeze? We really haven't in the past few years, but we think what happens if we go back and we look at our climatological records from the past 100 years, it's really fascinating to see how we will go through multiple mild winters. And we haven't been able to put our finger yet on why they'll set up the way they do. And then all of a sudden you'll just get smacked with a cold winter. And it's like, where'd that come from? I love talking to, don't take this personal, but old timers. Please, anybody that's old, don't get mad at me. That's meant to be it's meant to be a compliment because they tend to have such cool knowledge, especially if you can find an old timer arborist. They will tell you coconut palms were never, ever, ever supposed to be in Tampa Bay. But because of us people, you know, us humans, we want what we want. We went down to Miami and we grabbed them and we planted them in the ground here. And then guess what we got during 2009 and 2010? Really cold winters, 2 real cold winters back to back. They all died. And guess what people do? They go down there, they grab those coconut palms, they put them back in the ground. I love the look of them. So yeah, I mean, that's all it is. It's patterns. And it's fascinating to see how they come and go. We think this is going to be a pretty mild winter because of La Nina. And that usually means mild across the deep south.
Okay. That was another question. How does the La Nina affect our weather? And that's certainly one way. And
yeah,
kind of along the same lines, we have another question about what would the circumstance be that would set up for snow? I remember snow fell once when I was a little kid.
Yeah.
In Clearwater, I should say, right in the middle of Pinellas County.
So let's see here, everybody. Let's play a game. How old is James? Because if I remember right, that year was 1977, I believe, when we got the last snow on the ground. Technically, it did snow in the winter of 2009, 2010, and it did stick on the ground, but it came as far south as about the Pasco County line. And it fell from the sky in Pinellas and Hillsborough and Manatee County, but it didn't stick on the ground. But we did see little tiny baby snowmen on the ground in Citrus and Hernando County, 2009-10. But yes, 1977, we actually had snow in Tampa Bay on the ground. It only lasted for a few hours that morning, but it was on the ground. It was very impressive. And by the way, that's the winter where it snowed in Miami.
Right.
Farthest south latitude ever in history, 1977, that we had snow all the way down to Miami.
But I guess there had to have been enough atmosphere. Everything had to be just right.
Yes.
in order for that to happen?
And to answer that question, basically what you have to have is you have to have an Arctic outbreak. You have to have cold air that dives south with a really strong high pressure that shoves it so far south, it goes all the way down in the Caribbean. And then you have to have moisture come up and over it. So you'd have to have some weird thing where like a low pressure maybe comes from the southern Gulf or something. The cold air comes in and then the low goes up and over. That's what you have to have here. We're not going to get anything like, the Great Lakes, they get lake effect snow. I had somebody say, well, can we get Gulf effect snow? I think it would be about impossible. Maybe I shouldn't say impossible, but it would be really, really difficult because our Gulf waters never cool that much. So even if you get a strong wind off the Gulf, it would be too mild. So you can't really
Right,
get Gulf effect snow.
right. Well, as people might, as our lovely participants might think of a few more questions, would you like to just address the two that we had? Number one, how did you become a meteorologist? And number two, what's it like being a meteorologist?
How did I become a meteorologist? I was just fascinated by weather, and I was senior in high school. And back then, we were not nearly as good as students as what the students are now, where they're already knowing where they're going to college by late sophomore, junior years. I was not prepared. I wasn't thinking. I was just playing football and having a good old time. And guidance counselor goes, it's your senior year. You might want to start applying somewhere. And I thought, oh yeah, I guess I should. And I was one of those just aloof students that was just having a good time my senior year. And I said, well, how do I do this? Like, what do I do? And he goes, well, what are you interested in? And I thought, football. He goes, no, 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 no. Besides sports. And seriously, James, it was this simple. It was like, I like weather. And he goes, you can study it. And I went, really? You can study weather? And he goes, yeah, it's called meteorology. And it was like, that's so cool. I didn't know you could study weather. And so that's it. That's all it was. It was nothing fancy. And so all he did was he pulled out a book, because back in those days, there was no computers or internet. They broke out a book and dropped it down on the ground. And we were like, Florida State has a meteorology department. NC State has a meteorology department. Penn State has a meteorology department. He's like, where do you want to apply? And I was like, okay, those three sound good. That's all it was. It was so laid back. So I applied, and before I know it, I'm being invited to NC State to take a tour, and that's it. The rest is history. And I did not have any passion to get on TV. I had zero passion. That's not how it started. It started truly as I just love weather. And I did the calculus and the physics. If you don't like calculus and physics, that's okay. I didn't love it either, but I did it to get by and understand the meteorology. And then once I got through all that, by senior year, they're asking you things like, okay, what direction do you want to go? So I got internships. I worked for the National Weather Service for a little bit. I did some weather coding. I actually helped the National Hurricane Center with some of their weather programs and coding. And then I stumbled upon, luckily, a meteorologist said, hey, you can come intern with me at the TV station and just see what we do. And I did that. And before I knew it, I was explaining things. I was like, hey, this is kind of fun. And that's it. That's all it was. And so I stumbled into this. And as far as what is it like being a meteorologist, not to get too negative, but it was a lot more fun before about 6 or 7 years ago. Social media and the open access and the derogatory comments and the negative comments has really made it difficult. We, as meteorologists, we actually talk to each other about it. We have open air rooms where just meteorologists talk to each other about how angry people have gotten. And we can't really figure out why, because we're not standing on TV trying to lie or anything. We're just saying, hey, this is the best I got. I can tell you right now, a tropical storm will probably develop. It might affect our weather by Sunday or Monday. And all of a sudden I'll get a nasty email. You don't know what you're talking about. So I would say that it's still enjoyable, but I wish that people would just understand that social media doesn't mean say anything you want to say. It still means I'm a normal human being. I'm your neighbor. I'm your friend. I mean, literally, I live here too. And so that's the only thing I would say. But the good news is I have thick skin. I've had to learn to have thick skin in this business. And so a lot of times now I'm just like, whatever, blow it off. But it's still a fun career. It is. I don't know what the future holds though, because it's not, I don't think, linear. I don't think it's just TV. I find it to be, and here's a positive to social media. I will say it's not all negative. A positive is things like this. I have found that Facebook Lives and Zoom sessions are neat. They're fun. You get to talk with people in your community. And I wonder if that's the future, because the old days were you went home and you turned on the 6 o'clock news and you watched TV. Nobody really does that anymore. You don't have time. You might catch Bay News 9 at 10:30 at night. You might catch it one time at 9 in the morning. You just catch it when you can. So I have a feeling the future is more interactive like this, where I'm a meteorologist and we somehow, disperse information.
Well, Brian, we're certainly glad that you will take your time to come and talk to us, and we'll be your friends no matter what, no matter what you say. You've always got a friendly place to come in and help us understand this fantastic topic. We love having you here for these hours at a time, explaining some of these big concepts and bringing it down to earth for us. We look forward to having you back again in the coming months. Wrap up of hurricane season and everything like that. We've actually had a question. Someone's interested in some of the tools that are used in prediction, mentioning in particular the balloons, the buoys, and the satellites. So
Yes.
that might be an interesting topic to pursue in the future. But today,
Yes.
I think we will wrap it up. I want to thank Brian again for joining us. I'm sure we would all love to sit here for another hour, but we've got our lives to get on with and a beautiful day to go and enjoy. So thank you, Brian. Thank
Absolutely.
you, everyone, for joining us today, and we'll be in touch bringing you Weather 103 in the coming months. Thanks for joining us.
Thank you.
Bye-bye. Bye.
Thanks.